All right, pre-AP 11, let's take a look at radical operations. Let's see if we can get any interesting or like remember any details. One thing that we want to look at for radicals, right? That when we want to look at things, we're going to remember that if I have x to some power is equal to a, well, we can rewrite this as like the opposite operation that we've done this and that, and it would actually be, the new thing would be x is equal to some power, some root of a, right? It could also be rewritten as a to the 1 over n, right? That we're just taking the fraction exponent there. Like as the fractions that you might have learned that we did x to the n equals a. Well, then if I want to get rid of the n on the x, then both sides I need to take to the 1 over n, take to the 1 over n. That cancels, and then I'll just get the new thing, x is equal to a 1 over n, or that's my radical, the root of n, a to the nth root there, right? So that's a radical expression. The a is the radicand, n is the index, right? So we call this portion here, like it has a name, we call this the index. And that's kind of the basic properties that this follows. Some important points to mention here. Notes, right? Some things we do want to note. One thing that we want to note is I'm going to say a is going to be greater than 0, and I'm going to say n is even, right? So we're going to have some important properties if we have even exponents, right? That means, what that means together, we have two real roots. So let's put that together with some examples. So if I have x squared equals 9, then if I take the square root of both sides, right, then if I have x is equal to root 9, what that is for me is that x is either equal to -3 or x is equal to 3. So if I have that, if I have that here, right, that if x squared equals 9, well, there's two numbers that work here, right? That -3 times -3 make 9, or 3 and 3 make 9. So I'm trying to make this original statement true, right? This is what I want to focus on. I want to try and make that original statement true. So if I had a different number, even if I had x squared equals 6, x is equal to root 6, but that also means to me, or x is equal to negative root 6, right? Because both can work here, right? Root 6 squared is also 6, because I'm going to say root 6 squared is 6, and negative root 6 squared is 6. So anytime we square something, we're taking away the radical, right? And then also, even if we have a different exponent, like x to the fourth equals 3, I can take this and say, well, then x is equal to the fourth root of 3, or x is equal to the negative fourth root of 3. Because if we do both, if I do 4 to 3 like that to the 4, that just gets me 3 back. Or if I take negative fourth root 3 to fourth power, I will also get 3 back that way, right? Another case that we're going to look at here, so this is case 1. Let's look at case 2. Case 2 says to us, if a is negative, so a is less than 0, and n is even, no solutions, right? And so let's see as why there's no solutions, right? So what that means for us, if I had x squared is equal to -9, then x has to have no solution, or you can say no solution, because what two numbers itself, like what number times itself, is going to make -9? Well, if I did 3 and 3, that's +9, that doesn't work. And if I did -3 and -3, that's also +9. But if I did -3 and +3, well, that's 9. But those are two different numbers on the number line. That's 0, that's 3, that's -3. Those are two different numbers. -3 is not equal to 3, so no solution, right? Does not work. We cannot have negatives under a square root. So this, if we have -2 there, not possible, right? So we're not looking at that. As mathematicians, though, we're going to make something possible in the future, but for now, this is not possible. Don't put a pin into that as like that's the real true thing, but that's enough for now. Last one, or second last principle, if n is odd, right? If n is odd, so if we have odd exponents, right? Only one root for a. So only one root exists for a given base, for any given base. So anytime I have an odd exponent, it has only one root, any given base. It doesn't have a negative and positive pair. It just has a positive or negative pair. So for example, cube root, if I had x cubed is equal to 8, well then x is equal to 2, right? That's the only thing that works because 2 cubed is 8, right? And from this I would get cube root x is equal to cube root 8. And so that means x is equal to 2. So what else does this look like? If I had x cubed equals -8, well then x is equal to the cube root of -8. But this works because -2, this whole thing is equal to -2, because -2 times -2 times -2 results in a negative still occurring, so this will be -8. So -2 cubed is still -8. So with a cube or like anything odd, we can get a negative root back. So what about x to the 5th and a 4? Well, that just means x is equal to the 5th root of 4, right? So x is equal to the 5th root of 4. And that's just it. It has one root there. Okay, last note that we want to take care of. If a is 0, if a equals 0, then only one root, no matter n, except n cannot be 0. And that just means that if I have 0 to some n, that's always going to be 0, right? So if I had x to the 5, if I had x to the 5 is equal to 0, well then x is equal to the 5th root of 0, which is just 0, right? So that's all it's telling us. Absolute value, new thing that for some of you, for absolute value, all that we're looking at it is distance to 0, right? Distance to 0, right? How far is your number away to 0? But it also makes something positive. So what it does for us, that if I had 0 and I had some number a and I had -a, well then the distance here, right, if I had the absolute value of a is a. This is a units away. So this is a units away from 0 there, right? Then here, absolute value of a is a, and this is also a units away, right? Where a stands in for some number. So it's always measuring how far a is from 0. How we define absolute value is the absolute value of some number is going to be a if a is greater than or equal to 0, and it's going to be -a if a is less than 0. So a negative, and what happens here, why that is, it takes a negative, makes a positive. So if I have 5, well then that makes it 5 since 5 is already bigger than 0. And if I have -5 in my absolute value, that just makes it -5, and that makes it 5. So an absolute value works by multiplying it by a negative if you're already negative. Okay, so why do we care about absolute value? Well, when we take out, if we were to take out x squared like this, right? Well, that means I can take into account my positive and negative roots if they come out like that, right? So I can take into account my square roots like that. So properties that we want to look at, and we'll get into that detail about absolute value in a moment. Properties, we know that a to the 1 over n is the same as this radical of the nth root of a, like that. So that's property 1. Property 2 that we're going to look at, property 2, property 3, and property 4. Property 2 is a to the m over n, can be written as a to the 1 over n m, and makes our radical nice and easy, that we get to the nth root there, and then we can take the exponent. It's going to save us a lot of work if we take the root first and then take an exponent, or we simplify. If we have a to the negative m over n, well, what does that do for us? That negative just means that it goes to the fraction, so m over n, and we just treat it the same way, even so. So this is just going to be 1 over nth root of a to the m, like that. So we're just going to treat it like that. First one, and we can break fractions apart. So if I have n a over b like this, right, that's actually just the nth root of a and the nth root of b there, like that. We can break it apart. Okay. So whenever we're doing this, let's see. Like whenever we have an x squared, we can break it apart and becomes root of x. Because what I want to do is find for x is greater than or equal to 0. Right? I always want them to turn out like that. Because what happens is I can't take x squared, the root of x squared, for it to be negative 3 because it's under a radical, right? I can't have that happening. Even if I square it, then I get x squared is equal to 9, but then I lose the negative 3. So I have to have an absolute value sign around it. But now there's some where if I have x to the 4th and I took that, then I get x squared. Do I need an absolute value? No. No absolute value here. The squaring does that operation, right? The squaring takes care of it if it's negative or not. So the squaring does the hard work for us. We don't care if it's cubic or anything because that cubic, we're allowed to have a negative solution. So that's totally fine for us. If you want, you can read through the notes there on the cases. But really, we're going to drop that absolute value business pretty quick after this lesson. We're just using this to understand that for the true definition of a square root, or a, like, let's say a 6th root, like if we had a 6th root here, we would need to have an x, we would have to have x cubed over here as well too, right? That we can't get that information of whether it was negative or positive from the root after it's been evaluated. So a cube can be negative, right? But really, from a square root of x to the 6th, that had never was able to be negative. So we can't allow anything negative there. So if there was a negative x somewhere defined in it, we need a way of making it positive, and that's what the absolute value is doing for us. So whenever we get left over with a odd exponent from an even exponent after square rooting, we need to put an absolute value sign around it. Okay, even to even works fine. Even to odd, no. Odd to odd, well, I'd be impressed if you got odd to odd. Yeah, because we're always trying to find powers. Well, you could get odd to odd, I'm sure. Yeah, 21 over 7 makes 3. That's fine. I wouldn't be impressed. Never mind. I spoke too soon. All right, that's what's going on. So something to keep that in mind. We drop it pretty quick, but mostly this is just saying, hey, take a look at the rules. These are the definitions. They'll help you more in future math classes. Okay, perfect. Thanks so much. Have a good day, Pre-Calc 11.